Hello. In this video, I would like to discuss LLM as a judge. The evolution of large language model evaluation has shifted from static benchmarks toward more dynamic, scalable frameworks. Among these, the LLM-as-a-Judge paradigm has emerged as a cornerstone for rapid development. While early implementations focused on a simple one-to-one evaluation, the field has matured into three distinct architectural forms: the solo judge, the panel of judges, and the self-judging model. Each offers unique trade-offs between cost, reliability, and objective depth. The most common form of LLM as a judge involves a single, high-capacity model, often referred to as the strong judge, evaluating the output of a smaller or newer model. In this setup, the judge is provided with a prompt, the candidate's response, and a specific rubric. This method is the primary driver behind modern leaderboards, such as MT Bench, which uses a high-end model to score responses across various categories like coding, reasoning, and roleplay. A real-world use case for the solo judge is in regression testing for enterprise chatbots. When a company updates its customer service model from a smaller version to a slightly larger one, they cannot manually review 10,000 test cases. Instead, they deploy a frontier model like GPT or Gemini to act as a solo judge. The judge compares the old model's answers to the new ones, flagging only the instances where the quality has dropped. This allows developers to focus their human-led audits on the specific failures identified by the AI judge. Despite the efficiency of a single judge, LLMs are prone to identity bias, where they subconsciously prefer their own writing style or favor longer, more verbose answers regardless of accuracy. The panel of judges, or ensemble evaluation, mitigates this by using multiple distinct models, such as a combination of Claude, GPT, and Llama, to evaluate the same response. This wisdom of the crowd approach ensures that the flaws of one specific architecture do not skew the final assessment. This architectural form has recently transitioned from research labs into major consumer and enterprise platforms. A prominent example is Perplexity AI's Model Council. In this implementation, a single query is processed by three separate frontier models simultaneously. Each model generates an independent report, and a fourth synthesizer model acts as the presiding judge. This judge reviews the three outputs to identify consensus and contradictions, allowing users to see where models agree or where a specific model might be hallucinating. Similarly, Microsoft has integrated multi-model intelligence into its researcher agent to enhance the depth of complex workplace tasks. Microsoft utilizes two key features within this panel framework: counsel and critique. According to the Draco benchmark, Microsoft Research with Critique outperformed all other frontier models in deep research. The counsel feature allows users to run models like OpenAI's GPT and Anthropic's Claude in tandem to produce independent reports. Followed by a third judge model that summarizes the findings and highlights unique insights from each. The critique feature employs a dual-model peer review loop where one model drafts a report while a second reviewer model strictly assesses source reliability and evidence grounding. In the real world, these panel systems are frequently seen in AI safety and alignment research and high-stakes professional environments. When testing a model for helpfulness versus harmlessness, researchers may use a panel of three different models to vote on whether a response violates a safety policy. If two models flag a response but the third does not, the disagreement signals a borderline case that requires a human tiebreaker. This multi-agent consensus significantly reduces the risk of false passes and improves analytical rigor over traditional single-model workflows. Model counsel operates in parallel; multiple models generate responses simultaneously, which are then aggregated through a synthesis process. While Microsoft's counsel model resembles Perplexity's Model Council, in its critique mode, Microsoft employs a sequential approach. One model produces an initial draft, and a second reviewer model assesses and refines it iteratively to ensure factual grounding and analytical rigor. This distinction closely mirrors the concept of ensemble methods in data science, which involve combining multiple machine learning models to improve overall performance, stability, and predictive accuracy. Ensemble methods are generally categorized into two primary strategies: parallel and sequential. Model Counsel's parallel aggregation resembles bagging techniques, such as random forests, where multiple decision trees are built independently and their results are averaged to reduce variance. By contrast, Microsoft's sequential refinement aligns with boosting, where models are trained one after another. This is seen in techniques like gradient boosting, where an initial model is progressively improved through iterative corrections that minimize the residual error of the previous step. This parallel reveals a broader insight: certain foundational logics, parallel aggregation versus sequential refinement, transcend specific domains. It can be effectively applied across both traditional data science and modern AI system design to enhance reliability and precision. The last form is self-judging, which is often referred to as a reflection, or as self-critique, occurs when a model is asked to evaluate and then refine its own initial output. While it might seem counterintuitive for a model to grade itself, the process of externalizing a critique often allows the model to identify logical inconsistencies or formatting errors that it missed during the initial generation. This is essentially a form of thinking out loud that forces the model to verify its work against a set of constraints. A concrete example of self-judging is found in automated code generation. A developer might prompt a model to write a complex Python script. Before the code is delivered to the user, a secondary self-judge prompt is triggered. Review the code you just wrote. Does it handle edge cases for null inputs? Are the variable names PEP8 compliant? The model identifies its own oversights, corrects them, and provides a polished final version. This recursive loop significantly improves the first-pass success rate in software engineering workflows. As AI systems become more complex, the methods used to evaluate them must become equally sophisticated. The solo judge provides the speed necessary for daily iteration. The panel of judges, as seen in the robust counsel architectures of Microsoft and Perplexity, provides the objectivity and cross-verification required for professional research. And the self-judge provides the internal quality control needed for precision tasks. By moving between these three forms, researchers and developers can build AI systems that are not just faster, but demonstrably more reliable and aligned with human intent. So, which method do you prefer? I'd love to hear your thought. Please drop your comments here. Thank you for watching. Good.
Bye.